Hey everyone, this video is not about meat, but it's about cheese, and that's because this is personal. 5 years ago, I wanted to try my first Beyond Burger, so I went to a restaurant and I ordered one, and I got the burger. It looked great, smelled good, took a bite, put it down, left the restaurant. Because the cheese tasted so bad, it completely ruined the experience for me. So if you want to ask me, what does a Beyond Burger taste like today? I'm going to tell you it tastes like shit. I can't even tell you how the burger was, like the meat patty itself. All I know is the cheese completely ruined the experience. Vegan cheese gets a bad rep because it doesn't taste very good. Today I want to look at that a little bit more. I want to see what's vegan cheese made out of, why does it suck, is there good vegan cheese, how is real cheese made and how is that different from vegan cheese? How can we make all cheese vegan? I think we have the technology to make all cheese vegan, and it's super exciting, and it's something that most people aren't talking about. Now I've been seeing vegan cheese pop up in supermarkets, and I haven't touched the stuff for 5 years, and so I'm thinking, okay, maybe that means someone has finally solved vegan cheese. Someone's cracked the code, and now we have good quality product. Wrong. Vegan cheese still tastes like companies are just going to extract money from vegans so that they don't feel socially awkward at the family barbecue. If I was going to become vegan, I would just get rid of cheese altogether because I haven't found a cheese, except for cashew cheeses. Cashew cheeses are good. But I really haven't found a cheese that would keep me eating cheese. I've been trying vegan cheeses because I thought maybe now someone would have solved the problem. So I've tried, this brand Chow. I've tried Violife. People are telling me that that's one of the better cheeses out there. It tastes horrible. I've been trying. So Baby Bell just came out with a vegan cheese as well. It tastes terrible. The only good one I found is there's a company in Vancouver, Canada, and you'll find this with other artisan cheese shops, but Blue Heron, they make cheese out of cashews, chickpea protein. That's about it. And if you look at the ingredients list of their cheese, it's basically cashews cultures, or chickpea protein, coconut milk cultures, and then some salt. So there's not that many ingredients. But let's look at Violife and see what kind of ingredients are in here. So we have water, makes sense. Coconut oil, makes sense. Modified potato starch, okay. Cheeses don't have starch in them, but we have some starch. Modifying cornstarch, okay. Potato starch. Then we have the flavors: sea salt, olive oil extract, carotene for color, right? Because this is supposed to be a cheddar. If we look at the Chow brand, it's the same thing. We have water, coconut oil, modified corn, and potato starch. Potato starch, fermented tofu. So when I saw this is why I bought it, because it had fermented tofu, and I thought, okay, why is real cheese good? It's because you have fermentation, and that creates lactic acid, which creates some of the sour properties that you get in a pungent cheese. So surely fermented tofu would be a good cheese. No, didn't help, because this thing's made with starch. Primarily, it's made with starch. Starch doesn't go in cheese, and it just tastes bad. And they have a really small amount of the fermented tofu in this cheese. So honestly, this one tasted basically the same as Violife. Then you have your flavors, your salt, natural flavor, your olive extracts, which is used in these products as more preservative. And then you have beta-carotene from carrots, which is used for the color of the cheddar. If you look at Baby Bell, their ingredients are the same: water, potato, modified potato starch, coconut oil, salt. Okay, so all of these products are the same. They're made from potato starch. Apart from appealing to the vegans who need to, appear at a party with meat eaters, A, the ingredients that are used don't work, and B, the manufacturing process is completely different than normal cheese. So let's look at how normal cheese is made.
Cabot's newest farm facilities are using robotic milkers to speed up the process. Once the milk is collected, it's held in tanks until a Cabot truck arrives. To make Cabot's signature cheddar, first the milk is pasteurized. The milk is then poured into a huge vat where a starter culture of bacteria and the special enzyme called rennet are added in. This combo jumpstarts the process of curdling the milk into cheese. And as the cheese is formed, big steel wires break it down into small curds and a liquid known as whey. Once the cheese curds are cooked through, the whey and the curds head to the finishing table. Here, the whey is drained out. Salt is added in to cut some of that acidity. This is also the point where Cabot can add in herbs and other ingredients to make their specialty flavors, like super spicy habanero and the cheese for us weaker heat seekers, the pepper jack. After that, everything's mixed together. Next, the cheese curds are squeezed together to form massive 40 or 60 pound blocks. Those blocks are then sent to the aging room, where they're left in a temperature-controlled space to mature.
As we saw from the manufacturing process, cheese is a living, breathing organism that has cultures, bacterial cultures, and that's what ferments it, and that's what gives it the taste. Let's just take a look at how these vegan cheese products are made. This guy I absolutely love. He goes around and he makes amazing videos about different vegan products, and he's a great chef. Highly recommend that you check out his YouTube videos. I'm just going to show a clip from one of his BioLife videos because he goes and he makes his own BioLife at home. It's just going to give you a bit of a look at what the ingredients are. We'll just go from there.
So I've been on the hunt for a good plant-based cheese for a while. I've done a lot of different testing, I've made a few different recipes. Now, out of all of that testing and all of those recipes, one of the best vegan cheeses that I found, in my opinion, was the BioLife Sharp Cheddar cheese. Now, the ingredients of the BioLife Sharp Cheddar cheese are pretty familiar ingredients. They are filtered water, coconut oil, food starch modified, which they're using a potato starch and corn starch together. Food starch modified isn't genetically modified, it just means that the starches were changed to either be stretchier or more binding, or they're able to firm up better. Not anything crazy going on with those. And they have a mature cheddar flavor that comes from vegan sources, and they also use an olive extract, beta carotene, and they add B12. Now, the one thing that I want to focus on is the mature cheddar flavor. How do they get that? What exactly is mature cheddar flavor? I think I have a few ideas. Now, one of the things that makes sharp cheddar sharp is the sour taste, and that comes from lactic acid. Now, I have this lactic acid here, which comes from Druid's Groves. I'll leave a link in the description below, but this is a vegan-sourced lactic acid. It's vegan, which means that it comes from fermenting like cassava root or other sort of starches. Now, this lactic acid also includes lactic acid and calcium lactate. Calcium lactate is also another ingredient that's found in naturally aged sharp cheddar cheese. Now, besides lactic acid, cheddar cheese also gets a lot of its flavor from glutamates. Cheddar is on the low end of the glutamates out of all of the different cheeses. Parmesan cheese is on the high end, but that glutamate is still there enough to give it a very savory flavor. Now, we can find glutamates by using MSG, but we also have the mushroom extract. I use the mushroom powder quite a bit in a lot of my videos, and it works really well to add a glutamate, to add a very nice savory flavor to your recipes. So let's get started and make ourselves some BioLife cheddar cheese at home. I think we're gonna nail this one. So before we start putting this all together, we're gonna focus on a few individual components of this cheese. That's gonna be the beta carotene, which we're just gonna kind of pull from carrots. It's gonna help us color this. And then also the olive extract. Now, I'm not gonna really create an olive extract. I'm just gonna make an olive flavored component, just using olives, a little bit of water, and some oil.
Pretty self-explanatory. The ingredients make sense. You can make this at home. He has a great video if you want to follow along. And I like how he adds lactic acid to his cheese. I want to try his recipe because I'm assuming it's going to be better than this crap. Now I want to look at the blue Heron because they actually ferment their cheese. They make it from cashews. So you have the fats. This is more of a cheese product. This is something that I would consider a cheese. Let's look at their video and how they make that.
Cheese inspires many a romantic obsession. Traditionally made with animal milks, cheese is a relatively simple food, with few ingredients as a rule. A milk, salt, digestive enzymes, microbial cultures, and time. Cheese and cheesemaking are the outcomes of an accident of circumstance, cultivated into a craft, founded in science, and developed into art. Cheesemaking is continually evolving, and we are part of that evolution, setting out to create a new tradition. making 100% animal-free cheeses using a wide array of plant materials for our milks and a diversity of microbial cultures. We seek to create new cheeses with their own unique flavors, aromas, and textures. We are expanding the boundaries of what it means to make cheese. Each cheese holds within it a beautiful ecosystem of millions of microbes working in harmony with each other.
So I just want to look at their website. The foundation of our cheeses come from a variety of rich plant bases like cashews, coconuts, almonds, oats, lupins, and other legumes. Within their compact shells, these fruits and nuts hold the perfect balance of fats, proteins, and sugars, three simple elements that form the basis for all cheese. Next, we utilize microbes and plant-derived digestive enzymes to coagulate the plant-based proteins, right? So this is the exact same process as you see with milk. You curd the milk, and in this case, they're curding the plant milk and these plant fats. And so that's going to produce a much more identical cheese than you're going to find with the Violife of the world. Okay, so then the question is, it becomes, why don't we just make vegan cheese out of these plants, fruits, legumes that have high fat content? And well, it's because it still doesn't completely 100% taste like the animal version. And so while that's great, you're still not going to convert everyone. But then B, these input ingredients are really expensive. Cashews, nuts, they cost a lot of money. And so one wheel of this cheese, while it's artisan, so that probably also contributes to the price, really you're looking at the ingredients. And one wheel of this cheese, 175 grams, costs about $13. You're not going to get people paying for that, at least at scale. And if we're going to have the scale to grow all of those nuts that we need, that introduces a bunch of other problems. The scale challenge of, if we look at, can we make everybody vegan in 10 years, we're not going to achieve it with these current products that we have in the market. So we need to look at something else. Now I want to look at precision fermentation technology. Can we use this technology, which is essentially just a new manufacturing process for animal-based proteins, to create cheese that we would then be able to apply this manufacturing process to all cheeses today, so they would all become vegan by default? I think that's possible, so I want to look at a couple companies that are doing that.
I've been on a plant-based diet for 6.5 years, mostly because of ethics, sustainability, and health. For me, it was perfectly clear that it's not going to be the solution to ask consumers to sacrifice or get rid of all those amazing products by themselves, but actually the strategy or the approach to get there, to create a more sustainable food system, in my mind, really had to come from innovative technology. Formo is a biotech food company that is not like the solutions that you would find today in the market that are plant-based, so based on, cashew, coconut, and so forth. This is real cheese. It doesn't come from a cow, but is exactly the same.
To produce milk proteins in microorganisms, we had to look at the genome of the cow, and we identified the genes that are responsible for the proteins in milk. And we use those genes and bring them into the genome of microorganisms to give them the genetic information to produce the milk proteins. We then grow our microorganisms in small-scale fermenters, and we can extract the milk proteins from there. Our products contain milk proteins that have, on a molecular level, the exact same structure and amino acid sequence as milk proteins from a cow, which means that they have the same behavior in cheese products, they melt, have the same nutritional value. Our products will be vegan since they contain no animal products.
Cool thing is that because on a chemical, organic or molecular level, this is really the same thing. So what comes out is a cheese that we all know and love, very indulgent, functional and great tasting. Animal agriculture, it emits more greenhouse gas emissions than the whole transportation system. Dairy is responsible for 4%, which is roughly equivalent to the whole aviation and shipping industry. If you look at 1 kilogram of cheese, you can reduce the greenhouse gas emissions by 70–75% using our process. My hope really is that we can replace as many cows as possible in the system, that we can get rid of as much greenhouse gas emissions as possible.
Biology is incredible. We can build a better world by using nature. I'm Britta and I'm co-founder and chief scientific officer of Formo.
My name is Raphael Rotensinger. I'm the CEO and co-founder of Formo.
Now, Formo has said publicly on their website that they plan to produce 10% of all dairy, cheese, milk, butter, all dairy in Europe in 2030. Let that sink in. These are vegan dairy products. Instead of using the proteins and the fats directly from an animal, they're printed out from DNA sequences. How do we get that? Let's look into the sequencing of the genome.
You've probably heard of the human genome, the huge collection of genes inside each and every one of your cells. You probably also know that we've sequenced the human genome. But what does that actually mean? How do you sequence someone's genome? Let's back up a bit. What is a genome? Well, a genome is all the genes, plus some extra, that make up an organism. Genes are made up of DNA, and DNA is made up of long paired strands of A's, T's, C's, and G's. Your genome is the code that your cells use to know how to behave.
So we've sequenced the human genome. Can we do the same thing with the cow so we can understand what the DNA is so we can make milk?
Well, humans have 23 pairs of chromosomes plus the sex chromosomes, whereas cattle have 29 pairs of chromosomes plus their sex chromosomes. Although their genomes are about the same size, they're both about 3 billion base pairs.
Now, you may remember news stories about the Bovine Genome Sequencing project. That first mapping of the DNA took 5 years and cost around $52 million. But that price is coming down.
So, for example, a few years ago, genomes were costing about $10,000 to sequence to a similar depth as the Bovine Genome Sequencing project. And now, a new sequencer is rumored to come out where we could sequence the bovine genome to a 30x coverage for about $1,000 in less than a week.
Amazing. So back in 2009 was when we first sequenced the genome for the cow, including all the proteins for how to make milk. So now we have all of that data for the genetic blueprint of how to make all of these proteins and all of these cells online on a database. And this is no different from now how we have music. Used to only be able to get music on like a tape, or you could only hear it in person. And now we have the ability to have all the music, the entire library of all the music in the world on an online database, and that's called Spotify. Now, how do we take all of that data and turn it into milk?
Microbes are like little factories. And so in the same way that brewers use yeast to convert sugar into alcohol to make beer and wine, bakers use yeast to convert sugar into carbon dioxide to leaven bread. And yeast can also be used to convert sugar into proteins or sugar into lipids, into different kinds of molecules. And so yeast just basically rearrange carbon and other other atoms into and reconfigure them to make different kinds of compounds. And so, and all of those instructions are encoded by DNA. And so what we do is we work with the yeast that naturally makes protein, that naturally converts sugar into protein, instead of using the yeast that converts it into alcohol or carbon dioxide or something else. But then what we do is that instead of having the yeast make any kind of protein, there are online databases that have all of the proteins known to man. And by what I mean by those proteins is that, for example, hemoglobin, right? For the different kinds of egg white proteins, different kinds of dairy proteins, different kinds of human proteins, they're all online. And when you get the DNA sequence that codes for each of those proteins, there are companies out there that have been around for decades that literally print out, that synthesize that DNA and package it into like little tubes that then what we call plasmids, and those are already encoded for a specific protein. That protein that DNA sequence gets sprinkled into the yeast, And the yeast actually naturally, by poking little holes in their cell wall, you can integrate the DNA sequence into the yeast. And so as the yeast starts eating the sugar, instead of producing anything, it starts actually reading that DNA sequence as it metabolizes and starts producing that specific protein.
We've sequenced the cow genome. We have all the DNA on an online database to make any milk protein, any food protein that we could ever dream of. We have, for years, have had the technology to print out these proteins, print them out, create them in real life. We can put them in yeast, and the yeast will make more of those proteins. So we can make milk, we can make cheese, we can make all kinds of amazing foods because we have the technology now to do all of that. So I've tried ice cream made using this technology. Delicious. Tastes like any other ice cream that you'd imagine. It's not made from a cow. It's made, we sequenced the genome of the cow, now we're printing it out, but you don't have to do anything to the cow. It's like no touching of any cows required. So I've tried ice cream. I've tried cream cheese. Both are delicious. I want to try milk. There's a video that I made recently. It's now for sale in the US if you're interested. I really want to try cheese. There's lots of incredible companies making cheese. We just saw Formo Bio in Germany. There's many companies working on this problem. I really wish there was a way to invest in these companies because this is really going to be the future of cheese making. And this technology is manufacturing technology that can be applied to any cheese product in the world so that everything can become vegan. I really think that this is an incredible time to invest in these companies. I really wish I knew of a way to do that. If you have any ideas, let me know in the comments. See you in the next video.